today discuss about the another form of the state variable that are asked in exam. Okay, so first of all, I will explain. I will give you the explanation how that particular transfer function is obtained from that state model, and then we solve the numerical. Okay, am I audible now? Clear? Okay, so screen is visible to everyone. Visible. So here I am. See, this is the derivation, which is uh, here we derive the expression for the transfer function in terms of the A, B, C, and the matrices of the state model. Right. So we know that when we require the uh, transfer function, right? So we have here what we have. We have the state model. Okay. So you know that we write down the state model. So here you can see the transfer function from the state model, right? What we are doing, we just calculate, we just of getting or deriving the transfer function from the state model. Okay. So here on your screen you can see here we have this input, right? Means x dot of x is equals to a of x plus bu, right? And second equation is y is equals to c x plus du. This a, b, c, d all are the matrices, right? And you know that what is the dimension. Now what we do next? Next we take the Laplace transform from that. Okay. So when we take the Laplace transform, when we do this Laplace transform, so here you can see this x dot is when we take this Laplace transform. So here we get this s x of s is equals to a x of s plus bu, right? Either you can write down these values in the capital x of s or capital y of s, right? So here what I'm doing here, we just collecting all the terms on one side. Okay, so here you can see this is x of s, this is also a into x of s, right? Okay, this is we take this this complete term on the left hand side, right? So this equation becomes x of s minus a x of s. Now what we do, we just take this x of s common, right? When I take this x of s common, here I give I of I matrices. You know that I matrices is the identity matrices, right? And whose dimension is n by n, means what may be the dimension. Here we have of this A. So on that basis, we just doing that one. Right. Now we just what we do, on one side we have that complete term in the x of s, and on the right hand side you have the value that is matrix B of u. Is right, B of u. Now what we are doing, we just multiply, right? We just multiplying on both sides We just multiply, or we just say that it is a pre-multiplied. What pre-multiplied on the both side, that is a S I minus A whole bracket inverse, means 1 by minus 1, right? So when we are pre-multiplying this term, right, when we are pre-multiplying this term came here, and this complete term is came here. So this is 1 and this is minus 1. So you know that here we have only the x of s, and the x of s is equals to, this x of s is equals to, in bracket, s I minus matrix A whole bracket inverse into B matrices, right? Now this is one equation. This equation is obtained from this x dot is equals to ax plus bu, right? Now we consider the second equation, that is y is equals to matrix cx plus du, right? Again we take this when same, and we just calculate the value. When we are calculating this value, when we're taking the Laplace and transform, so here you know that this is x of s. You already calculate this value of x of s here. Okay, so you just put the value x of s here, and when you are getting this value, that time you came to know that that this is C, this matrix C as it is, matrix C in bracket S I minus A inverse, complete bracket inverse, into matrix B is U of S plus D U of S. Right. Now you know that you take the Laplace, you know that this is the transfer function. So when you take the transfer function, okay, when you take this transfer function, that is Y of S by U of S is equals to, right, Y of S by U of S is equals to matrix C into, in bracket, S into I minus A inverse B plus D. Are you getting? So in this way, you obtain the transfer function from the state model. Okay, in this way you obtain the transfer function from the state model. You know that in the transfer function, in the state model, you have all this matrix value. That is, you know that what is the A, what is B, what is C, what is D, right? But here, what we are doing, by collecting or by considering all the matrices value, when you put this matrix value in this complete equation, that time you get the transfer function of that particular state model. Okay, so in this way, we just calculating this transfer function. Are you getting my point? Now, okay, so you can note, okay, I will explain you completely, then we okay, on that on this derivation we have one numerical here, right? So you can see on your screen here we have the question that says that find the transfer function. Okay, question says matrix x dot 1 x dot 2 is equals to, this is 2 by 2 matrix. Okay, this is 2 by 2, this is minus 5 minus 1 3 and minus 1. Variables are x1 and x2 plus 2 5 r of t, and this is your y equation. Okay, this is your y equation. So this y is equals to, this y is equals to 1 2 and this variables x1 and x2. Now first of all what we are doing, we just taking the all the matrices value. Okay, first of all we require the matrix A value, matrix B value, matrix C value and matrix D value. Okay, so when I require this value, I know that this is the matrix A, this term is the matrix A, this term is the matrix B, this term is the matrix C, and this, and plus plus this du, right? Like this, we have that state equations. Okay, so first of all, your duty is to uh, take all the matrix value. So here you can see, here we have that is A is equals to, in bracket, matrix 2 by 2 minus 1, sorry, minus 5, minus 1, 3, and minus 1. Matrix B is 2, 5. Okay. Matrix C is 1, 2. And here, if we don't have the value of D, right? So that time we consider that this is the 0. Okay. So in this way, we just considering the, sorry, we just considering the matrix value. Now you know that when this question asks that is can find the transfer function from the state model, so that time you know that the formula is the how we calculate the transfer function. So transfer function is equals to matrix C in bracket Si minus A whole bracket inverse into matrix B plus matrix D. Okay, so we using that same equation here. Okay, we just using that same equation here, and we just calculate the value step by step, that is matrix by matrix. Okay, we are not able to calculate directly this bracket inverse, right? We are not able to calculate this value directly. First of all, we require this matrix and then we take the inverse. Okay, so and this way we just calculating these values. So we just go from inner to outer side, right? We just calculate the innermost matrices first, then we move outside. Okay, so first of all we just consider this as S into I minus A matrix. So you know that here we have the size of this A is 2 by 2, right? You know that this value is 2 by 2. So in that same manner, we just consider this identity matrix set. Okay. So here we have, sorry, here we have 1 0 and 0 1. When we multiply this S, so here we get this S 0 and 0 S. Okay, so in this way we get the matrix value S into I. Right now we know that what is the value of A. So then we put the matrix here, right? That is Si minus A. So when I put my value here, so here that is this is matrix A. Okay. Or okay, for more simplification, you can write down here, right? And this is your matrix B. Right. Now you get the value, that is S minus is S plus 5, 1, right? 0 minus 1 is plus 1, that is, right? That is 0 minus 3, that is minus 3, and S minus of minus 1, that is a S plus 1. Okay, so in this way you get this Si minus A. Okay, now once you get the value, that is Si minus A matrix, then your duty is to calculate the inverse one. So how we calculate the inverse? We just calculate the inverse. That inverse is addition by delta. Okay, so here, first of all, we just take the addition. So here, that is mod of Si minus A. So for this, what we are doing, we just when we have this 2 by 2 matrix, that replace the this diagonal elements, right, and change the sign of the next diagonal elements, right? Means we change the position 1 1 and 2 2, and we change the sign, that is 1 2 and 2 1 positions. Okay, so in this way you get this one. Next target is to calculate the determinant. For this determinant, we have this is cross multiplication, right? that original matrix. Right, this one. So here we get in bracket s plus 5 into s plus 1 minus or minus 3 minus 3 into 1. So here we get when you are calculating this complete equation, after this calculation means after this calculation what you get? You get this s square plus 6s plus 5, okay, and this is plus 3. Okay, when you calculate this value, then you get the value that is s square plus 6s plus 8. And when we create a factor, so here we have that is s plus 2 in bracket and s plus 4 in bracket, s plus 2 and s plus 4. Okay, so here you get, in this way you get this value. Means finally you get the value of this, that is si minus a inverse. Okay, in this way you get the value. Now we just go next step, right? We just calculate this inner bracket, then we multiply with the matrix C. So what is the value of this matrix C? That is a 1 2. This 1 2. Okay, so here we have this, value, right? This is value, right, here, and here we have this matrix C. When you multiply this one, when you multiply this complete two matrices, right? So first of all, I just give all these value. First of all, we just do this one operation here, and then here. So here we get this one. So finally, after this operation, that is C, matrix C in bracket Si minus A inverse is equals to, that value is equals to S plus 7 upon S plus 2, S plus 4. Okay. And the next value is the 2S plus 9 upon S plus 2, S plus 4. Right? Now, in this way, you get this one. Means you get up to this value. That is a C and bracket. Right? Next is multiply with the matrix B. So, you know that what is the value of matrix B? Matrix B is the 2, 5. Right? That is 2, 5. Right? So, multiply with this one. So this is row and this is your column. When you multiply this value, right? When you multiply this value, you get this equation, right? Means here, right? It is s plus 7 into 2 denominator as it is s plus 2 s plus 4, and second is the 5 into, that is in bracket 2s plus 9 upon s plus 2 s plus 4. Okay, so when you multiply this complete equation, when you multiply this matrices, finally you get the value that is that value is the 2s plus 14 plus 10s plus 45 whole divided by s plus uh, this value, that is s plus 2 s plus 4. Okay, now when you simplify this equation, means that is a 2s plus 14 plus 10s plus 45. So here 2s and 10s is gives you that is 12s. Okay. Are you understanding? So it just here you can consider easy to you. Here you get is 2s plus 14 plus 10s plus 45. Right? And when you simplify this complete equation, you get this final value. Right? Okay. Now, up to this point, you have means you when you simplify this complete equation, you get this answer. Right? Then that is last matrix, that is D. So it is zero. That value, this value is zero. Are you getting? So here, finally, this is the transfer function. Okay. So you can say that, you can say here that transfer transfer function is E of s is equals to, let's derive this matrix B, right? Right. So in this way, you get or you obtain the transfer function. You obtain the transfer function from the state model. Okay. In this way, you obtain the transfer function from the state model. Okay. So this is how we get the when we have the state model equations or state model variable in by using that transfer function or by using that formula, right, matrix. So we have obtained the transfer function from the state model. In some of the numericals, they directly give you the matrix value, means matrix A, matrix B, matrix C, and matrix D value directly. And then the question asks to you that determine the transfer function from this given matrix data. Okay, so what we are doing here, we just take the value with, from this equations, that is matrix A, B, C, and D, right? And in that particular numerical, they directly give you this value, that is A, B, C, and D. Now again, your task is that to calculate the transfer function, and you know that you have this equation with you. Okay, so by using this equation, by using this, you can calculate the transfer function from the state model. Okay, I think you will understand. So